Okay, let's check on exercise 2.2D first. So you look at question number 2. You're given matrix C and D. Show that matrix D is an identity matrix. So what you do is you are going to multiply both with the identity matrix. Okay, so we multiply C and D. You can just write down CD like this. Okay, is equal to negative 1, 3, 2, 5 multiplied by 1, 0, 0, 1. So you do the calculation here. Okay, after that you will get this matrix, which is the same as matrix C. Okay, so it's equal to matrix C. And then you solve the other one on the right. Okay, this one, the other way around. Okay, whereby D multiply with matrix C. Okay, you show the calculation and then you get the answer, which is exactly the same as matrix C. So you already know that CD multiplied by DC is equal to C. Therefore, D is an identity matrix. Okay, because the matrix that multiply with an identity matrix, it comes up with the matrix itself. It's an identity matrix. We continue with question number 3. Okay, for question number 3, you're given matrix S and also matrix T. So I just asked you to do question B and C over here. You have to find out in bracket IS multiplied by T. Okay, so what you are going to do, you are going to replace the value of S, the identity first, then followed by the matrix S, followed by matrix D, but then this one in bracket. Okay, so we solve the one in bracket first. Therefore, you will have 7263 for IS multiplied by T. Okay, show your calculation and you will get this one. 11, 15, 3, 18. Okay, then you look for C. C is 4IT minus I squared. So the I here, you know that it is an identity matrix. So you copy down everything. 4 times identity matrix multiplied by matrix T minus the identity matrix times identity matrix. Okay, so usually you know that anything multiplied by identity matrix is actually equal to that number or that matrix itself. But over here, I still show it to you. So 4 times identity matrix, you will get 4004 like this. Copy down this one. And then this one multiplied by identity, you still get an identity matrix. Okay, there's no changes at all. Followed by your calculation. So you minus the identity matrix here. Okay, so this part you will get 12, 4, negative 20, 16, minus the identity matrix. So when it comes to minus identity matrix, you have to minus that. It's not multiplication. If it is multiplication, then you will get the matrix itself. Okay, so over here, 12 minus 1, you get 11. 4 minus 0, it is still the same. Negative 20 minus 0, you get negative 20. 16 minus 1, you get 15. Okay, so we move forward to self-practice 2.2e. Okay. In self-practice 2.2e here, I asked you to do question number 1, A, B, and D only. So we look at A first. They ask you to determine whether the following matrices are inverse matrices of one another. If they are the inverse matrices, so you will know that it comes up with how to determine the inverse matrix. It must be an identity matrix, right? Okay, so let's see here. Okay, you are going to do the multiplication. The first one, 5, 4, 3, 2 multiplied by 2, negative 4, negative 3, 5. Okay, so this is the calculation whereby you multiply the row with the column and you get this. Multiply the row with the column, you get this, and so on. Okay, so lastly, the answer is negative 2, 0, negative 2, 1. Okay, so this is not an inverse matrices because it doesn't come out with an identity matrix. Okay, so now we move to B. B is 1, 3, 1, 4 multiplied by half, 3, 1, 2. Okay, again, you show your calculation and you will get 3.5, 11, 4.5, 11. Same with this one because there's no identity matrix as a result, so it is not an inverse matrices. Okay, now we move to C. So C, you multiply it just like the one given in the question. Show your calculation. So you get 1001. Okay, so this is an identity matrix. So the answer will be yes. The matrices are inverse matrices of one another. Okay, so do you have any question for these two exercise class?
No.
Any question? No question, huh? So we continue with the lesson. Yes, no, okay. Then we continue with the lesson today. Okay. I saw the attendance is quite low again. So before I start, you go to your Google Class, we take a while. Go to your Google Class. I want you to take your attendance right now. This one for today. Okay, 6th afternoon. I want to see who are not here. And not forget, you have to hand in your work for the one that we just discussed, which is 2.2D and 2.2E. One already turned in very fast. Diana, very good. Okay, the rest, please do so. Okay, so we go back to the attendance. I want to see. 9 turn in. Again, this one you can see it due at 9:10. So after this, you cannot take your attendance anymore. Make sure you do so right now. It's for your own good, actually. So we have 27 now. But I still have, okay, 4 to go. Okay, now I think I can start already. So previously, you learned about the identity matrix and also how to find out whether it's an inverse matrix or not. If it is an inverse matrix, then you have the result or the product as an identity matrix. Okay, so today what you are going to learn is you are going to find out what is the scalar of the inverse matrix and also find the determinant. Okay, so from here, this activity, the mind mobilization 4 here, I show it to you some of the answer already. This is to determine the inverse matrix of a 2x2 matrix. Okay, so you can see the question here, the activity sheet. It is given that A is equal to A, B, C, D, and the inverse matrix of A here is equal to P, Q, R, S. Okay, so if you follow the instruction, I did everything for you because I want to make it fast. So multiply matrix A and the inverse of matrix A. So you will have the AB multiply with PR, you get AB plus PR, and then this will be AQ plus BS and so on. So I did one by one to let you see. Okay, and copy down here, everything is the same. Okay, now they said form 4 equations from A to the power -1 is equal to I. So they made the equation equal to identity matrix like this. Okay, therefore the first element over here is equal to 1. So you can see this. The second element over here, you can see it is equal to 0. This one. And so on. Okay, these two. After that, with the substitution method, hopefully you still remember how to do the substitution method for solving the simultaneous equation. Okay, follow the instruction over here. Use the equation in 1 and 3, these two. Express P and R in terms of A, B, C, D. So hopefully you still remember if with the substitution method, for example, the one here, AP plus BR equal to 1, this will be the first equation. And then this one, CP plus DR equal to 0. This is the second equation. So you are going to continue by finding the value of P and R from these two equations. You are going to solve it. So from what we get, from what I have over here, you can see the P is already given. It will come out with P equal to D over AD minus BC. And the R will be negative C over AD minus BC like this. Okay, same thing with this part, the second column over here, they ask you to use the second and the fourth, these two. Okay, express Q and S. So you're going to use the substitution method to find out the value, not the value or the formula for Q and S. So this is the result here. Okay, after that, write matrix, the inverse matrix of A in terms of A, B, C, and D. Okay, therefore the inverse matrix of A, you just substitute everything here because it is P, Q, R, S. You remember up there, the matrix, inverse matrix of A is in the form of P, Q, R, S. So you just substitute everything, the value into matrix, inverse matrix of A. Okay, so you have these 4 elements in, okay, and then write the inverse matrix of A is scalar multiplication. So if we write down in the form of scalar multiplication, you can see all of these contain AD minus BC, AD minus BC, AD minus BC. So it will be 1 over AD minus BC, and the rest will be D, negative B, negative C, negative A. They factorize it. Okay, so the factor is 1 over AD minus BC. Therefore, from here, from this activity, we find out that, okay, this is the finding here. The scalar is 1 over AD minus BC. Okay, remember this word, the scalar, meaning that the bigger the scalar, your matrix is getting bigger. The smaller the scalar also will show that your matrix is getting smaller later on. Okay, and then for B, the element A, 1, 1 is D. Okay, what does it mean over here? I'll show it to you. You are given A, B, C, D. So the element of A11, this is A11, meaning that it is first row, first column is D. So it is D here. And then element A12, 12 is first row, second column. So first row, second column, meaning that it is referring to this. So it is negative B. Element A21, 2 is second row, first column. So C is the one, is negative C. And element A22 is this. So it is an A. Okay. So note that the position of A and D are exchanged while B and C are multiplied by negative 1. So you got to remember this. Originally, you have A, B, C, and D. But then, okay, after the mind mobilization, you will find out that it is exchanged. These two exchange becomes D, A. And then these two, you add on the negative sign. So it becomes negative B, negative C. Okay, so we continue here. Given matrix A is equal to A, B, C, D, so the inverse matrix of matrix A can be obtained using the formula as follows. So this one is very important. If you're given one matrix and then you are asked to find out the inverse matrix of that particular matrix, so the formula will be 1 over AD minus BC, this is the scalar, multiplied by the matrix over here where AD minus BC cannot be 0. So you understand already why it cannot be 0 always. If it is a 0, then meanings it will be undefined. You cannot have the answer. Okay, and then we look at this part here. This part is very important. I already make it a star over here. Okay, look carefully. You have to understand this part. Okay, once you understand this part, you can solve the rest of the problem already. If you don't understand, it's very hard for you on how to start solving the problem. Okay, first thing, determinant. What is determinant? Determinant for matrix A, it is written like this. Okay, whereby you have two straight lines. Sorry. You will have a two straight line and the A like this. If they said determinant for matrix B, then you draw like this. Determinant for matrix B. Okay, so we continue here. Determinant for matrix A is AD minus BC. So this is the determinant, like this one. This is the determinant. Where AD and minus BC cannot be 0. It's not equal to 0. Therefore, inverse matrix A exists. Okay, if it is not 0, meaning that there is an inverse matrix of A. If your AD minus BC is equal to 0, then the inverse matrix of A doesn't exist. Okay, so you got to make sure only when it is not 0, there will be an inverse matrix. If it is 0, there's no inverse matrix. Okay, so inverse matrix does not exist when AD minus BC equal to 0. Not in mind, Remember again, when it is equal to 0, there's no inverse matrix. Okay, now we look at example 23. We are going to try to solve this question here. For each of the following matrices, determine whether the inverse matrix exists. Like just now, right? You have to find out the determinant first. If yes, calculate the inverse matrix. So only if you have, then you calculate. If you don't have, then we stop there. Okay, for the first question A here. A is equal to 1, 2, 4, 8. So we need to determine whether the inverse matrix exists or not. Then you have to find the determinant, whereby AD minus BC. We need to find out how much is AD minus BC. So AD is 1 times 8. 1 times 8 minus BC is 2 times 4. 2 times 4. Okay, so it is 8 minus 8. It is equal to 0. Okay, meaning that the determinant of matrix A is equal to 0. Can it be 0? Cannot, right? If it is 0, so the inverse matrix of matrix A does not exist. So we can answer this question already because of the determinant is equal to 0. Hence, the inverse matrix of A does not exist. Okay, and then now we look at B here, question B. Same thing, if you want to find out whether the inverse matrix exists, we are going to look for the determinant first. So AD minus BC for this matrix, it is equal to, AD is this, 3 times 4 minus 5 times 2. So 3, 4 is 12. 5 times 2 is 10. It is not equal to 0, right? When it is not equal to 0, meaning that the determinant, meaning that there is an inverse matrix. So you can write like this. The determinant for matrix B is not equal to 0. Hence, the inverse matrix of matrix B, okay, this is the how you write it, the inverse matrix of matrix B exists. Okay, now when it exists, they ask you to calculate the inverse matrix. Okay, how to calculate the inverse matrix? Again, you are going to follow what you have got earlier, this one, this part. Okay, this one, you see, when the inverse matrix can be obtained using the formula as follows. So you are going to use this formula here. For example, if it is matrix A, to find out the inverse matrix of matrix A, it will be 1 over AD minus BC, you multiply by this. Okay, so using the scalar, you multiply by the matrix. So I show it here. Okay, so the inverse matrix of matrix B, we write it down, move it further to the right. B, negative 1, the inverse matrix of matrix B, it is equal to 1 over AD minus BC multiplied by, this will be the A exchange with D already. D, A, negative B, negative B, negative C. Close it. Okay, so from here, you refer back to this. 1 over the AD minus BC, we already got the AD minus BC just now, which is 2 here, remember? Okay, which is 3 times 4 minus 5 times 2. And then this part, the D is 4. Okay, you get this, you exchange it. The A is 3. The B is negative 5. You add on the negative sign. And then the C is negative 2. Okay, so this will be 1 over 2 multiplied by 4, negative 5, negative 2, 3. And you continue with the answer here. 1 over 2 times 4, we get a 2. 1 over 2 times negative 5, it is negative 5 over 2. But then you also can change it into a mixed number if you want. We also can leave it this way because there's no penalized for this. So negative 1 over 2 times negative 2 is negative 1. Negative 1 over 2 times 3 is 3. Sorry, 1 over 2 times 3 is 3 over 2. So that's the answer for the inverse matrix. Okay, So you just need to remember, whenever you were asked to find out the inverse matrix, you are going to use the formula to solve it. Okay, now we continue with example 24. Okay, if you look at example 24 over here, you're given matrix C equal to 2, -6, 1, -2. Calculate the inverse matrix of C. So easy already. It's just like the question that we did just now for question B. So what you do is, you're going to find the inverse of matrix C by using the formula. So inverse of matrix C, C to the power of -1, is equal to 1 over AD. So A is 2 multiplied by -2 minus BC. BC is this 2. So it is -6 multiplied by 1. After that, multiply by, again, these two will exchange, 2 and -2 will exchange position because A and D is exchanged already. So this is a 2 down here. And then this is negative, what? Just remember negative B, right? So when you multiply with a negative number, this -6 becomes +6. And then the 1 here becomes -1. Okay, then we continue to do the calculation. So this is 1 over 2 times -2 is -2. -6 times 1 is -6. So -2 minus -6 becomes -2 plus 6. -2 plus 6 is +4. Okay?
-4, madam.
-4. Yeah, correct. -4. I made mistake. Thank you. 2 times -2. Correct or not? Let me see.
Madam, 2 times -2 is -4.
Correct, -4. Thank you. So it is -4. I write down first. Plus -6 times 1, 6. Okay, so -4 plus 6 is a 2. Okay, 2. So this is -2, 6, -1, 2. Okay, then you multiply it. 1 over 2 times -2. So the answer is how much?
-1.
Yes, correct. 1 over 2 times 6, you get 3. 1 over 2 times -1 is -1 over 2. 1 over 2 times 2, yeah, sorry. 1 over 2 times 2 is 1. Okay? Correct, right? Any question?
No.
Question? Okay, we continue. Yeah, what happened? Okay, so we continue with example 25. Okay, example 25 is here. Okay, given matrix D is equal to M, -6, 1, -2. Calculate the value of M. So you need to calculate this one. Matrix D, if matrix D does not have inverse matrix. If matrix D does not have inverse matrix, what does it mean? It means the, what do you call it already? The AD minus BC. Yes, correct. The determinant AD minus BC will be equal to 0 if there is no inverse matrix. Okay, so we are going to look for the determinant over here. Right now, A. Okay, so the AD minus BC is equal to 0. So we are going to find out A is M. Oh, sorry, A is -2 because it's already exchanged position, but that doesn't matter lah. AD minus -6 times 1 equal to 0. Okay, so -2M minus -6. If you are fast, you change it straight away, becomes +6 equal to 0. So the -2M is equal to the -2M is equal to -6, correct? So the M is equal to -6 over -2. The answer is 3. Okay, so this is the answer for the M. And then for B, they give you the inverse matrix of D. They ask you to calculate the value of M. So what you do is, you know that if we multiply the matrix D with the inverse of matrix D, which is D to the power of -1, we will have the answer as an identity matrix. Okay, so what you do is you are going to substitute all the value of the D and the inverse matrix in here and make it becomes an inverse matrix, the inverse identity matrix, sorry. So this is M, -6, 1, -2. And then the inverse matrix of matrix D, you follow this. It is -1, 3, -1/2, 1. Make it equal to identity matrix is, you have to make sure the order is the same, 1, 0, 0, 1. Okay, and then from here, you are going to find out one by one, but then you just need to find out the one that it involves M lah. You can see from here, the one that it involves N. This times this is equal to 1. So M times -1 plus -6 times -1/2 is equal to 1. So M times -1 is -M, and then -6 times -1/2 is a +3 equal to 1. So your M is equal to 1 minus 3, -M. 1 minus 3 is -2. So to change your M becomes positive, it is equal to 2. Are you okay? Are you
Yes.
okay, class? Yes, Okay, so we move forward to the next example, 26. Okay, this is 26. It is given that this matrix over here multiplied by A is equal to 1, 0, 0, 1. And matrix A has an order of 2 times 2. So 2 by 2 is the same. Everything is 2 by 2. So you have to calculate the matrix of A. Okay, which means over here, you still remember A multiplied by A, inverse matrix of A, you get an identity matrix. So meaning that if it is given A over here, you are looking for the inverse matrix of A. So to look for the inverse matrix of A, you have to use the formula of 1 over AD minus BC multiplied by DA negative B negative C. Okay, so we are going to substitute all the value over here to find matrix A. Okay, we are looking for matrix A. So this is matrix A. Okay, so 1 over AD minus BC will be 1 times 8 minus 2 times 3. Okay, exchange the position. So it will be 8 and 1 here. And then this one, you add a negative sign, becomes -2. This is -3. Okay, we calculate the scalar first. 8 times 1, 8 minus 6 equal to 2. Let's continue. This is 8, -2, -3, 1. 1 over 2 times 8 is a 4. 1 over 2 times -2 is -1. So the rest, this is -3 over 2. This is 1 over 2. Okay, so that's the answer for matrix A. Are you okay, class?
Yes.
Yes, fine. Okay, so we move forward. Okay, I think that will be the, okay, yeah, it's the exercise already. So you take out your textbook, turn to page 62. I'm going to give you exercise. Okay, look at self-practice 2.2F. You only need to do one exercise for today. I want you to finish everything over here. 1, 2, 3, 4. Okay, now let's try the first question, everybody. You take out a piece of paper. Everybody, just to make sure whether you can do it or not. For question number 1, you go and get a piece of paper. I give you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so make sure you have paper. You also have to get your pen or pencil. No pen or no pencil, you cannot solve. So you look at question number 1 here. For each of the following matrices, Determine whether the inverse matrix exists. This is just like first example. If yes, then you calculate the inverse matrix. So let us determine first. How to determine whether the inverse matrix exists or not? The determinant must be
Not equal 0.
not equal to 0, correct. So can you find the determinant right now? AD minus BC. I think you calculate in your mind also can. Is there an determinant? Okay. Now I'm going to ask question. Okay. Rushdina, you hear me? Rushdina? You were absent in the last lesson. Rushdina not here, left already. Okay, Matthew, then Matthew. Matthew? Hello, Matthew.
Yes, madam.
Okay, Matthew, refer back to this question just now. Can you determine what is the determinant for this one? What is the determinant for question A? The determinant is AD minus BC. Have you found out what is the determinant for it? Very simple, right? Because
6.
very good. So if it is 6, I don't want Matthew already. Thank you, Matthew. Now I change to other people.
Welcome.
Okay. Ahmad, Ashad. Ashad, are you there?
Yes, madam.
Okay, Ashad. When the determinant is 6, is there an inverse matrix?
Yes, madam.
Yes, thank you. So we only don't, the inverse matrix only doesn't exist when the determinant is equal to 0. So for this one, if the inverse matrix exists, then you have to look for the inverse matrix. Okay, next person. Who shall I pick? Zawani. Zawani, are you there? Zawani? Okay, Zawani, can you tell me what is the formula to get the inverse matrix? What is the formula to get the inverse matrix? Can you use your mic?
1 over AD minus BC.
1 over AD minus BC. After that?
Then D, negative B, negative C, and A.
Okay, very good. So everybody understand? This is the two things that you learned today. One is a scalar. This one you call it determinant. And then this is the formula to get the inverse matrix. Any question, class?
No questions.
No questions. So I'll stop here today. I think we don't have to continue with the tutorial. You go back and do your exercise. After that, remember to take your attendance and also turn in your work for today. Okay? So I'll see you in the next lesson. That is the next Wednesday. Okay, class?
Okay, thank you,
Okay,
madam.
bye.
Thank you, madam.
Thank you, madam.
Welcome. Bye.
Bye, madam.
Yeah, bye.